Hello and welcome to Let's Code an Indie Game episode 7. This is the series where we go through the tools and techniques needed to get started with independent game development. In this episode we're going to continue working on our room class, and we're going to fix the fact that currently our slimes ignore the fact that rooms exist in the game. Let's quickly review where we got to last time and talk about what we're going to do this episode. Okay, so let's just run our game straight away this time. Oops, need to open up a file. Let's do that. Okay, so we have a player, and our player can navigate through our rooms, and at the moment our rooms just have a different randomly assigned color, so we can tell when we change. But we can see that although our player changes location, our slimes currently just sort of ignore the fact that any kind of room transition is going on. So we've got two options. We could either move our slimes in the same way that we move our player. So let's quickly take a look at our map class. And if we look at our next and previous room functions, we see that whenever we move room, we swap the side of the screen that the player is on. So if the player exits the screen on the right, we make sure that they start the new room on the left. If the player exits the room on the left, we make sure that they start the new room on the right. So it looks to the person playing the game as if the player has walked in that direction and is now inside of a new room. So we could do this for all of our entities as well, but instead we're going to move our entities so that they're managed by the rooms, and this will give us an idea of two different kinds of entity for our game. We'll have entities which we expect to live for longer than the given room, and entities which we really only expect to live for the length of the room. And they'll get tidied away at the end of every room. So let's go ahead and think about the changes we would need to make that happen. So if we take a look at our create room function inside of our map, and just remind ourselves that this gets called whenever there are no new rooms for the player to enter, we make one using the create room function, and this just calls room.create for us. And if we take a look at room.create just to remind ourselves, we can see that room.create just assigns the room a random background color, and it wires up a couple of functions, and then it returns us an instance of the room. So if we want our rooms to manage the entities, it would make sense to introduce a table into the room to hold all of the entities. So let's go ahead and add that to our room instance and just put it equal to empty table. Cool. And now it would make sense if whenever we updated the room, we went through all of our entities and we called update on them. So let's go ahead and do that as well. So we can just use a for loop here, and we can say for, and we don't really care about the order the entities are in, so we'll put the number into an underscore just to show that we're ignoring it, but we do care about the entity, and this should be in self.entities. And now we can just call entity update and pass in our game, and we'll make sure we use the colon so that we call it as an instance method and pass in a reference to itself. Because if we take a look at our entity class, we can see that the update expects itself, and it expects the game object so that it can make decisions based on the game state. So we'll just make sure that those get passed in here. Okay, so if we run our game at the moment, nothing should have changed. So let's just make sure. Nope, we have an error. So it's always good to make a small change, check that nothing is broken. So room Lua line 14, attempt to call a table value. Let's take a look at line 14. So I think this is because, nope, it's not because of that. Of course. We need to wrap self.entities inside of ipairs so that we get an iterator for our for loop. So we were just passing in the table, and that doesn't work in Lua. Basically, you need to, if you want to use a for loop, you need something which has the iterator properties so that Lua knows how to loop through it and get the next value. So if we try this, good. We see that nothing in our game has changed. And that's because currently the entities still live in our game state, they don't live inside of our room because we haven't added them yet. The other thing we'll need to do is to draw all of the entities when our room gets drawn. So let's actually draw those last inside of our draw method so that they're on top of the room background instead of behind it. And again, we can just use a for loop. We'll remember I pairs this time. And here we can just call entity.draw. And again, quick check that everything is still working. Looks good. Okay, so how are we going to actually get the entities into our room? Well, let's go with the simplest way to start with, and then we'll see if we can make it any nicer or any more convenient. So to start with, let's just pass in the entities we expect to be inside of the room. So room.create doesn't take any arguments at the moment, so we'll just add a new one. And then down here we can just do instance.entities equals entities. And this means inside of our map.lua function, when we call room.create, we probably want to pass in at least an empty table or some entities. So let's go ahead and create a table to hold our entities, and let's just start off with a single slime. So inside of map, let's pull in our entity class. This is source.logic.entity, I think, but we'll just check. Yep, and we will also need to pull in our sprite class. Which is in source.graphics.sprite. Okay, so now when we create a room, we will create a new sprite, a new slime entity, and then we will include it in that room when it gets created. So let's make sure we have a slime sprite available. Oops. Slime sprite equals sprite.create, and we just need a path to our sprite here, which is assets sprites slime.png. Let's just check that we don't need anything else. Entity.lua. Oh no, sorry, sprite.lua. Sprite.lua. Yeah, if you've noticed, I sometimes get sprites and entities confused. I think because they were the first two classes we really made, so it's been at least 3 days, so I've forgotten all about it. Right, so sprite.create just takes an image path, so we should be absolutely fine. And then to start with, let's just do entities1 equals entity.create, and we know that when we create an entity we pass in a sprite, we pass in an x value, so let's just roughly in the middle, so 400, 300, a z value will start at 0, and what else does entity take? Always worth checking. Speed and movement. So let's jump back into map. So let's give them a speed of say 4, and we need to pull in our movement strategy as well. So, and we want to follow the player. And this was in source logic AI movement follow underscore player, I think. So the reason I'm using underscores in file names is just because I think it looks nicer. It's as simple as that. It's slightly faster if you don't have to switch between lowercase and capitals when you're looking for files on the command line. I don't like using spaces just because if you do use command line tools, it makes it much more difficult to type out the name of the file. Okay, so the last argument here should be follow player. And finally, we just want to make sure we pass in our entities when we create a room. Let's see what happens. Okay, bad argument number 1 to iPairs. Expected table got nil, room.lua, line 18. Of course, we now have rooms in the game which do not have any entities. And this is because inside of our map, if I remember correctly, yes, we create the first room, we create automatically when we make the map. So that's probably a bit of a code smell there. It feels a bit strange. It was okay when we started, so we may come back and fix that later. For now, I'm just going to pass in an empty entities table and see what happens. Okay, so we still have all of the slimes which are inside of our game state class, so we need to go back and tidy those guys up. But if we move to the next room, we should have an extra slime who, if we're fast enough, should disappear, and we remember where he is when we move, or she is when we move back into the room. Okay, progress. So let's go ahead and take out our slimes from our game state. And this is also a good opportunity to get rid of this test room variable, which I forgot to get rid of last time. It's always good to be deleting code. Okay, so this was the code which was adding random slimes to our game state. And we also had a line down here as well, so let's just go ahead and it should be okay to get rid of all of that. Okay, so now we just have a player in room 1, and if we move into room 2, we straight away have a slime. Room 3, we have a slime. And in every room we will have a slime. Okay, and finally let's make our rooms, well, not finally, but for the last piece of our messing around with the slimes, let's make our rooms a bit more interesting. So if we know it works for one slime, sorry, I want map.lua. If we know it works for one slime, then it should work for many slimes. So inside of create room, we can just use the same technique we used inside of our main file to for I equals 1 to, let's say 5. We can go ahead and fill the empty entities table with a sprite, with an entity, with a slime entity at the index of I. So entity.create, and let's again just for our x position we'll do math.random, and we know the screen is 800 wide, and we know that it is 600 high. So in an episode, hopefully very soon actually, I think we need to cover it quite soon, we'll go through how we set up the exact size and resolution of the screen and all of those things. But for now we're just using the default values, which is 800 by 600. So in here, let's go ahead and use our random x position and y position. Make sure we're all saved. So we have nothing in our first room, and in our second room we have 5 slimes at random locations. In our third room we have more slimes at different locations. Cool. Okay, so something that is worth taking a look at and probably fixing now is if we look at all of the code we have to pull in just to create one slime, that's starting to get a bit difficult to manage. So let's move the slime creation somewhere else. Let's actually capture and when you're doing, I guess, maybe professional programming, it just sounds like a bit of a terrible name for it, it's just a bit pretentious, but you often call this the domain concept. So if our domain is the game, let's actually capture the domain concept of a slime in some code. So we can go and look at it later. And then because it's captured, we can fix it, improve it, and look at it, and all of that good stuff. So inside of Where shall we put it? Actually, let's just create a brand new folder, and let's call this folder mobs. And this is where we're going to put all of our NPCs, all of our enemies. So new file, and we'll call it slime.lua. And now we can pull in all of the code we need to create a slime. So that's require, what am I doing? Local sprite equals require source.graphics.sprite. Local entity equals require, and you might just be asking, why don't I copy paste the code? Well, you know, I find it therapeutic, and it gives me more opportunity to talk to you guys if I just type the code out. Source.graphics.sprite, source.logic.entity, sprite entity follow player equals require source logic AI movement follow player. And I find if I do this, I think about what I'm doing a lot more. If I just copy paste my code around, the chance of me going back and fixing it and making it easier to use is that much smaller. Okay, so in here we can just create a function. Actually, let's do it properly. So let's say local slime is equal to empty table, and then we can return our slime module. And then we can do slime.create is equal to a new function. We don't need any arguments at the moment. And here we can return entity create, and we need the slime sprite. So let's just pull it out up here for now, because we don't want to reload the sprite every time we create a slime if we can help it. So let's go ahead and do local slime sprite equals sprite dot create assets sprite slime.png create slime sprite, and actually let's pass in the X position and the Y position that we want to create our slime at. So X pos, Y pos, we always want to start on the ground. We want a speed of 4, but I'm actually now going to pull that out into a variable. So it's not a magic number that we don't know what it does. We know that it's the speed. And finally, we can pass in follow player as our movement strategy. Okay, so now if we go back to our map, we can just go ahead and do local slime equals require source.mobs.slime. You can get rid of these 3 lines, and in create room we can get rid of this line, and we can replace this line with, not all of that line, just the entity.create we can replace with slime.create xpos ypos. Let's see what's broken. There we go. Everything is working, and our code is just, it's a tiny bit neater. And also, I think the thing to realize here is now if we want to go in and change anything about our slime, we go and we look in the file called slime, and that just makes it much more maintainable. It's just that much nicer to work with. And if you're going to be working on a code base for a long time, it's worth putting some time into making it as nice as possible to fix and to carry on developing. Okay, I'm going to leave it there for today. I hope that was useful for people. Please do like and subscribe if it's useful, or even better, if there's anything you'd like me to do differently, let me know, and I'm very happy to work with that feedback. Hope you're enjoying the series so far, and have a great evening. Goodbye.